Says here, Myra either walks, cycles, travels by car or travels by bus to work each day, okay? And here are the probabilities of her choice of travel, okay? Walk is missing there. And it says in part A then, calculate the probability that on any randomly chosen day she walks to work. So we need to fill that in essentially, okay? Now, it's quite easy to do because all the probabilities must total 1, okay? If you think about it, probability is on a scale from 0 to 1, where 0 is impossible, 1 is certain. So if we have all the possibilities, it's got to add up to 1, isn't it? Because it'll be certain that you will go on one of these at least, okay? Any one of them. So we need to see what that is there, what's left over from 1. So what I would do here is I would add these up, right? Now when you add them up, don't do it quickly. Okay, take your time, even if there's not much room here. Okay, and when you're adding them, line up the decimal points, okay? People who do this, line up the decimal points and take their time on it, to adding, are the ones who get it right. People who rush this, okay, often make mistakes, okay? So when I add these here, I want to see what the probability of bike, car and bus add up to. I've made certain I've lined up the decimal points here, and in the answer then, the decimal points will line up. So you can see then there's a gap there, so if you want to, you can fill that with 0. Okay, so now we're going to add them up. So we start on the right hand side. 5 add 0 add 5 is 10. So put 0, carry 1. 4 add 1 add 2 is 7. Okay, add the 1 then is 8. And then of course all those zeros then is just 0. So those 3 add up to 0.80. Okay, or if you want 0.8. It's the same thing, isn't it? So what's left then? Okay, from 1. Well, all I've got to do then is 1 take away 0.8. Okay, and that's like saying 100% take away 80%, and you're left with 20%. Of course, it's 0.2. Okay, right. Part B. It says what is the probability that on any randomly chosen day she either travelled to work by car or by bus. Okay, car or bus. Well, it's these probabilities here, yeah? Now, she either goes by car or bus. And when we see this word or in probability, or means to add, okay? So we literally got to add these two together, okay? Because it's either option, right? It's either this or this. They're combining the probabilities, okay? So you're opening it up. You've got more chance, if you like, of being one of those, okay, when you're combining them. So I literally need to add them. So when you see that word or, remember to add them. So again, line it up. Now there's nothing there. Okay, so nothing, add 5 is 5. 1 add 2 is 3. And then the 0 there. So the answer is 0.35. Part C then, it says, what is the probability that in any randomly chosen week might travel to work by car on the Monday and by bus on the Tuesday? Now these are independent events. She can do both of these. In part B, she could only do one of them, either car or bus. That's why we combined them and added them. Here she can do both of them. Alright, because they're on different days. So she can go by car on Monday, bus on Tuesday. And they use this word and here. Now in probability, and means to times. Okay, so on Monday, car is 0.1. And then on Tuesday, bus is, what is bus? 0.25. So we've got car 0.1, bus 0.25. I literally want you to times them, okay? Because they're independent events there, and you see that word and, right? Now when you times them, times in decimals is easy, isn't it? Because remember, you just ignore the decimal points. And in this case then it'd be 1 times 25, which is 25. And then you go back to the question and realise there's 1, 2, 3 decimal points in the question. So if there's 3 decimal points in the question, there's got to be 3 in the answer. Now 25 accounts for 2, so then you need to put a 0 in front to count for the third. So it'd be 0.025, 3 decimal places in the answer, because there's 3 in the question.